now we're going to see the constructive interference with multiple sources of light. So here we have the screen, the gradings, the number of gradings would be the number of sources that we have. So we can put light through this. We would see projection here in the screen. If we graph now here with radiance, and here could be the intensity of the light, we would see, instead of the pattern of a double slit experiment in which we had something like this, that here we have a, or something like this, we have a maximum and a minimum, maximum and minimum, so alternating. Now we would have here this maximum, and then let's say that we have I don't know, let's say four sources or 4 gradings. So we have n equals 4, we would have 1, 2, 3, and then this 1, 2, 3. So here we would have remember we have sine theta is equal to n lambda over n. So this would be the first one, n lambda over n. Here n lambda over n, where n is, any integer. This is the 0 order, first order and second order. And if we have n equals 4 in between this, we would have 3 like minimum. This is the general formula. So in the double slit experiment, when we have 2 apertures, n equals 2, we will only have between 1 and the other, we have only 1, that is 2 minus 1 is the same as here. So this is for multiple sources. Now, if we use white light, so let's say that we put white light. In the experiments that we did, we usually used, for example, green light, and we see the maximum, the minimum, etc. But if we put white light, the wavelength for each color is different, so wavelength is different. So here we would see in the projection, we would see, for example, here the maximum for the red, then another maximum for the red, maximum for red, something like that. For green or the other ones, we will see it at other places, like this. But always the 0 order for all the colors would be here exactly at the center, that is when theta is equal to 0. And then we will see this, that first we have one color always, and then the other color. If we put on top of this a green light, we will see the pattern for green light, and the green light will be exactly at the points in which with white light we have green color. And if we increase the number of apertures, we will change the width of this, and also the width of the, also if we change the width of the aperture, we will change the width of this, of how big we see this point. And this one, that is the zero order for all the colors, would be the brightest point and the wider point that we would see. So this is the multiple sources. Is a more general form for the double slit experiment, and just don't confuse with the single slit experiment, in which the pattern of diffraction, here we actually, in the previous video, we graphed, here could be x, remember that I use it at the vertical distance. Here is the intensity, and we have these patterns of by k, something like. and here the destructive interference, and the formula is for the minimum in the single slit experiment is the same as for the maximum in the double slit experiment. And so here this x is n lambda L over the width of the aperture, that is A.